Hello, my name is Mr. Rogers, and you're watching the video lecture notes for our brand new unit on chemistry. And this is actually going to be jumping ahead. We're actually in Chapter 2, Section 1, and we're starting with the basics here, starting with the parts of an atom to really get us thinking about chemistry. And so the parts of an atom, I know we talked about them already this year once, but I want to kind of run over them again. A couple basic parts here of an atom. We have first on the outside, we have the electrons. An electron is a negatively charged particle that moves at high speeds outside the nucleus. So it's kind of spinning around in what's known as the electron cloud. It's very, very, very tiny, very small, has very little mass. It moves at very high speeds, so fast we don't really know where it is at any one time. It's kind of here, it's there, it's nowhere, creating that electron cloud. Now, deep in the middle then, we have the nucleus. The nucleus is the center of the atom. It contains two particles. It contains the protons and the neutrons. It also contains most of the mass of the atom because protons and neutrons really have all the mass. So these two particles in the nucleus, first we have neutrons. Again, they are located in the nucleus. They have lots of mass and no charge. So the number of neutrons can change in an element. And finally then, also in the nucleus, we have the protons. Protons, again, are in the nucleus, have lots of mass, and have a positive charge. So my quick science joke of the day, two neutrons walk into a bar and order a drink. Bartender says, "For you, no charge." The neutrons look, "Are you positive?" Bartender says, "Hey, I'm a proton." There's your science joke of the day. So tell that one to all your friends. I'm sure they'll get a kick out of it. All right, guys, moving on to what an atom, kind of the basic structure of an atom. And on here, I would probably write this down, put the sketch in your notes. We have our basic parts again here in the middle. This is more of a 2D model. You got to think of it in 3D, where in this electron cloud, the electrons are going everywhere, not just on the sides. So in the middle, deep in the middle, and this is way too big. Nucleus is not proportional here. This would be very, very, very small. Deep in the middle of the atom is the nucleus. And the nucleus contains those two parts, the neutrons and the protons, which have a positive charge. Neutrons have no charge. And whizzing around the outside in different levels, we'll talk more about here in a few minutes, are these electrons. These very, very tiny particles, and much smaller than what you see here in comparison. And they're negatively charged. And they really whiz around, creating that electron cloud on the outside of an atom. So some facts about atoms we need to know. The way to think about an atom is that in the middle, that nucleus, that's really where most of the mass comes from. Those protons and neutrons really make up virtually all the mass, other than a very, very small fraction that the electrons have. It all comes from the protons and neutrons. On the opposite side of that, most of the volume of atoms comes from the space that electrons move around in. So there's a lot of empty space actually in atoms. There's a lot of empty space where those electrons can really buzz around, and like I said, they move really fast. They're so fast we can only predict where they're going to be at any one time. Now, there are some special electrons we want to talk about, and these are called valence electrons. And valence electrons are the farthest from the nucleus and the most loosely held onto, so they are often shared or lost by other atoms. Really in that outer shell we're going to talk more about here in a minute. So valence electrons, simply put, are the outermost, the farthest away from the nucleus. They're closest to the outside of an atom. Now, a number of valence electrons that an element has can determine a lot of properties that the atom has. We can predict where it'll fall in the periodic table based on the number of valence electrons, but also, how is it going to react with certain other elements or not react with other elements also, all based on that number of valence electrons. So it's kind of a very important fact to understand about an atom, what these valence electrons do. And finally here, we have, what happens with these valence electrons. We say they can cause different elements to bond together. So a chemical bond forms between two atoms when valence electrons move between them. So these electrons may be transferred, like they give them or they take them. They also can be shared, so they're kind of sometimes equally sharing, sometimes there's kind of unequal sharing, almost like a tug of war where they're pulling on. They're both kind of using that electron to complete that outermost shell. So if you want to stop and write it down, that's fine. I'm going to move on here. To our next sketch, I would, again, put this in your notes here. Here is kind of, again, a very, very basic model of an atom. And here in the middle is the nucleus. Like I said, this is way bigger than it actually is. And again, there's that nucleus in the middle, and it contains the protons and neutrons. And now we have these different rings coming outside the nucleus there. And we refer to these as the different electron shells. And what scientists have figured out is that this first shell, this first innermost shell, can only hold 2 electrons. Hold 2 electrons to fill up, and then that shell would be happy. The atom's happy then. As we move outwards here, we have our second shell, and this can hold up to 8 electrons. There's actually different ways to kind of look at this. There's actually a 2-8-8 rule where some of these third one would also be 8 electrons in that third shell. Here we'll say that it can hold up to 18. So up to 18 electrons can be in this outer shell. So we're going to focus mostly in our unit on the 2 and the 8. That third shell can hold up to 8. And again, it's kind of a way of predicting where these electrons are going to be. And scientists have figured out that depending on the type of atom, the type of element that it is, it's going to fill up these shells. It's always going to fill up the inner shell first, then the next shell, and the next shell. So it always kind of works its way in and works its way out. That's kind of how we, again, this talk about more chemical bonding will come up in the next couple of days. It's all based on if these shells are filled with valence electrons, the outermost ones, and that kind of determines if it's happy or not, so if it's going to bond or if it's not going to bond with other atoms. All right, so we're going to stop there today. Appreciate you guys watching, and we'll see you guys down the road.